made from 4 boards nailed together as shown. If the nail can each support a shear force of 100 pounds, okay, determine the required spacing in X prime and S if the beam is subjected to 700 pounds of force. Okay, so we're saying that the beam, right, the beam V is equal to 700 pounds. Okay, so the force fastener force resistance or nail force resistance and this is equal to 100 pounds, right? This 100 pounds, and then we are given, so we want to find what is our S prime and S. So the S is the horizontal spacing of the nail. The S prime is the vertical spacing of the prime of the nail. Okay, so this question you have to find IZZ, but I'm just going to write it out. You can go and find IZZ on your own. Okay, so it's 337.43 meter to power 4. Okay, so we are going to look at the spacing, but before I do that, let's draw the nails. Okay, let's draw the nails. So this is our cross section. So you have one like this, right? Then you have your horizontal nail. Then you have your vertical. Okay. So your shear force is coming down from here. Okay, your shear force is coming down from there. And we know that this is equal to 700 pounds. Okay, we know that 700 pounds. So how the shear flow will move, right? So before I go on, we will have a nail down here, right? And then we will have another nail coming on the vertical. So all the greens are all the nail. So how the shear will flow, right? So the shear will flow this way. Watch how I construct the shear, okay? So the shear will flow this way. Excuse me. So the shear will flow this direction. Okay, so this is how the shear will flow, your Q. Now, some of you say, now, Eugene, I am bloody confused now. Yes or no? Right? Why did the shear flow that way, right? Huh?
Does it come from the edges?
Eh? Say it again.
Why does it come from the edges like that?
Yeah. So if you look at the other example they've drawn, right? If I look at the example they've drawn, there's one more I draw the shear flow. Where is it? Yeah, this one, right? How come the shear flow will go from the center and then go this way and then go this way? Yes or no? Right? This is because the shear flow will want to transmit from the top and go down to the what? To the bottom, right? So when you do this nail first, okay, when you draw this first, the first set to draw, okay, so I'm going to sketch out something similar, right? So why I drew that arrow, right? So we know that this is V. We know that the shear flow will want to go down this direction, right? Everything want to go from the vertical to the bottom. So for that to occur, all the shear flow has to move this direction for continuity purposes, nothing else. Okay, so is after your term test, I have another chapter to go, so that you have to construct your shear flow also. Okay, so this is just a introduction for you guys. Okay, right. So the next thing that we're going to ask, so we're going to find the spacing. Okay, we're going to find the spacing okay, the spacing for the horizontal nail. Right. So the horizontal nail is the nail over here and the nail over here. So what is the spacing? Okay, so the formula to use, right? The formula that we're going to use is again the same, is equal to small q is equal to VQ over I, and this is equal to the shear force per nail or resistance force per nail divided by the spacing. So the rules still apply. You still have V is a constant, Q as the only thing is what is this Q, right? What is that Q now? So we know that what is the purpose of the horizontal nail? Anyone? What is the purpose of horizontal nail?
Just to keep the side.
Yeah, to keep the
Pieces
side.
on.
So the first moment of area that you have to consider is just here and here. That is all, right? That is the first moment, because the purpose of the nail is to keep the side into the main structure. Yes or no? That's why this question is interesting. Okay, so there's another dimension you have to know now. Okay, so from here, your Q now. So we are going. So the Q will be what? Q will be 2. Why 2? Because you have the what? Left and right. You're telling me, Eugene, why not we just calculate one area? We can't do that. Why? Because our V is a what? It's a constant. We can't do that. Okay. So 2, the area, the width is 1, right? The depth is 3, right? And then the spacing. So I will not. I will not do. I've not found this. You guys will have to find this. The centroid. Okay. So the centroid from the top is equal to 3.35448 inches cube. Okay, so for this is equal to 3.3548 minus by 3 over 2. Okay, so this will be equal to 3.3548 minus by times by 3 times 2 times 1. So it's equal to 11.1288. 11 inches cube. So from here, we apply Q. So V, we know is 700. Q is 11.1288. Divide, okay, so VQ over I is 337.43. And then this is equal to your force. Okay, so twice, because you have left and right. Nail multiply by the force of 100. We know it can withstand 100. Divide by S is the spacing we want. So therefore, S will be equal to 700.1288 divided by 337.43 divided by 2 divided by 100 is equal to 0. No, there's something wrong. 700 multiply by, no, 2 times 100 divided by 2 times 100, 337.43 divided by 700 divided by 11.1288 is equal to 8.66. The 8.663. Okay, so this is your horizontal spacing. Okay, so that's straightforward. So for your vertical now, right, you have to consider your first moment of area. You also have to consider this part. Okay, you have to consider this part for the vertical nail spacing. So yes.
Sorry, Eugene. I said Z. Would that be the units be inches to the fourth on that, or is
Yes,
it?
you're right. You're right.
Okay.
Yep.
Thank you.
So inches to power 4. Okay. So now the next one is we want to find the spacing. So this is just taking first moment of area. You guys will say, yeah, this is easy now. So spacing for the vertical nail, right? So this will be equal to Q is equal to the Q of the small web plus by Q of the flange, right? So the Q of the small web we found earlier is 11.1288 plus by the width is equal to 10. The depth is equal to 1. And the distance is equal to the y bar is equal to 3.3548 minus by 1 divided by 2. Okay. So this is equal to 11.1288 plus by 3.3548 minus by 0.5 times 10 times 1 is 28.548. So this will be 11.1288 plus a 28.548. So it's equal to 39.6768 inches to power 3. So therefore, so we know that with higher what? With higher Q value, first moment of area, the spacing will be closer. Yes or no? So this will be equal to Q will be equal to 700. I'm almost done. Okay, I know you are all tired. 6768 divide by second moment of area, 337.43 equal to 100 divided by S. You don't need to multiply by 2 down here because down here there's only a what? There's only a single nail. Okay, so from here, S will be equal to 100 times by 337.43 divided by 700 divided by 39.6768 is equal to 1.2149. Okay, 1.2149 inches. So this is for the vertical nail. As expected, isn't it? Right? The vertical nail is taking more loads. So to withstand 700, you have to space it together more. So that's all for today. And this is where I'm going to examine you up to test you for your term test. And I will, okay, tonight I will work extra late. Okay. I will post the homework tonight. There will be no quiz for next week. And next week's your term test. Any questions so far? Anyone?
I wasn't clear on what the small webs were for. Is that
What, the what?
stiffen it, or
The what? The small what?
the small webs on the sides?
Okay, you have to consider the small web for the first moment of area. Oh,
Yeah.
you are asking me what's the purpose?
Yeah.
Yeah, there's no purpose. It's just aesthetic, whatever. It's just a
Okay.
question comes like this. Okay, the questions comes like this. Okay, maybe it can be it can be used for aesthetic value. You want to hang something by the side. Who knows? Okay, I know engineers we think practical, but people who are in arts they are not. I understand that. Okay.
Okay. Thank you.
Right. Any other questions? If not, I will stop recording and I'll see you guys. So you all know that the term test is written online, right? Okay. So I will keep you all informed how many questions there are, whether is it going to be